Hey guys, welcome back to the shop. We're going to go ahead and get started on next phase of this rotary welding table build, and this time we're going to go ahead and start working on the grounding, the ground block here, the whatever you want to call it. I call it a grounding block. And I'm going to go ahead and address a couple issues that a lot of my viewers have commented on and people have concerns about. When I talked about this in the past, I didn't really go into full detail on how I was going to mount this up. I gave you this, just some idea that, you know, I'm going to bolt this down. We're going to use these bars. We're going to go around a shaft. A lot of people have concerns about, you know, isolating this from the base plate, which I had already planned to do. I just didn't talk about it before because I was going to wait till we get to this episode here. So we'll go ahead and address it now. But by the way, this is just a sleeve that I machined and dropped down in here. You know, it's just got a few thousandths clearance over that 3-inch bore, and this is turned to 2 7/8. So this is used to kind of like mimic, you know, if that shaft was sticking up through there. All right. So a lot of the concerns that everybody had was that just simply bolting this on there and sticking my ground on it, you know, I'm still going to be transferring current through this plate right here, you know, and up and so forth. But what I decided to do was isolate it, and I was trying to decide on what I wanted to use, what material. So I kept thinking about it, and I went hunting, and I've got a lot of plastics and things, and I went through Granddad's toolbox, and I found what I was looking for. And this is a piece of phenolic. And phenolic is a non-conductive material, and I've seen it used in electrical panels and things like that. But this is a sheet that was in Granddad's box that is just about the perfect size, I guess. It's 3/16 thick. I would have liked it to be a little bit thinner, like 1/8, but this will work. You know, this is something that I've got. So what we will do, I'll probably use this side here and cut out we're going to cut out a block of this. So that'll be between the copper block and the steel plate, the base plate. All right. So that's what's going to separate the two. Non-conductive material, that should work really good. Okay. We're going to, the bars right here will be mounted to this block like so. They're not going to be touching the plate either, you know, so they'll be mounted here. There should be some clearance underneath there. All right. So we got another issue, and again, this is something that a lot of people brought up, and I had already knew what I was going to do here, but a lot of people already give me the comments that, hey, you should. But I'm going to bore these two holes out. We'll probably go to 3/4. That's just a good round number right there. We'll probably go to 3/4. They're 1/2 inch now. So I've got some more phenolic right here. There's a piece. This is a piece here also. This is 1 1/4. That's 1 1/2. And what we can do, I can chuck this up and we can machine 2 flange bushings. So I'll drill and ream this out, say 3/4, and I'm going to machine some bushings out of this phenolic here. And they'll have we'll probably make, like, say, a 1/8 thick flange and make them a very light press and press them in there. And then whenever we go to bolt this on there, the washer and the bolt and everything will be isolated from, you know, the current there. It'll be going down through the center of that, pulled down on it also. So the current should not go through this into the bolt and into the plate and so forth. So that's what we're going to do right there. And one other thing is one of my commenters, one of my viewers, left me a cool comment and had a better idea on how to attach my ground to this block right here. And I was talking about cutting this out right here, and actually it kind of looked like that. You know, I was going to cut these out and just have a little block there that I can stick my ground on sideways. Well, one of my viewers said, hey, instead of cutting all that out, why don't you just mill a slot basically And I was like, man, that's a good idea. So what we'll do is we'll mill like a slot in here, okay? Let me just grab my ground here. So what we'll do is mill us a slot that will fit up in there like that. So it'll actually be kind of sitting on there like so. So there'll be a gap there that this part of the clamp, it'll clear and it'll go up inside that block right there. And the phenolic will be in between it also there, so it'll be about like that, about like so, with the slot milled in it. So that was a good idea. It's something I didn't think about. So I forget who made that comment, but I appreciate it. That was a good idea. So we'll incorporate that into the idea, the plans here also. And another thing, a lot of people want to see me put a spring on the backside of these bars. That was something else that was running through my mind before we talked about all this. So we're going to go ahead and incorporate that into our design also. I'm gonna put some radiuses on these bars, and then hopefully kind of straighten them back out here, so we can attach us a spring there to kind of keep them pulled together. So we're going to go ahead and include that also. Hopefully that'll put a lot of you guys' concerns at rest there. And then we got one more thing to talk about, and that is my thrust bearing. And we've had a lot of people concerned about my thrust bearing and say that, hey, you're messing up and you're going to weld your bearing. But I don't think that I am. I think what I'm doing here is plenty adequate. But what I had planned to do with this since the beginning was, I'm going to make, at work we've got some plastic shim stock in the gearbox shop there. I'm going to take some of that plastic shim stock, and I'm going to make me a couple donuts that will, basically same size as the race right here. And I'm going to use those to isolate the thrust bearing. So it'll be sitting on a very, very thin piece of plastic gasket material. And I think that'll work just fine in case there ever is that chance of that current trying to come up through these steel balls right here. I really don't think that it's going to happen, but that's what we're going to do though. So just wanted to fill you in on that. So all right, we're going to go ahead and this is still quite a bit of work, so I don't think we're going to make it all into one video. I want to go ahead and take care of this first, the big copper block. Maybe try to get this piece cut out right here, and get the flange bushings made for those right there. Okay, we'll try to get that done, and then we'll forming up these bars and attaching the spring. That's probably going to be plenty of video right there for a separate, whole separate video for you to watch. So let's go ahead and jump on this. I want to do some milling. I want to square it up and drill and ream these out. All right. I went ahead and picked up the first hole there. We got her indicated in, and I got the drill, and I've got a reamer there also. I'm going to use to ream the hole. So being copper, a little sketchy right there, trying to drill that stuff out. What I decided to do, I'm going to always call it the Keith Fenner method, because I learned this trick through him, and that is engaging the feed and using the hand wheel to move your tool in. And you can even put some resistance on it with the quill lock so that it doesn't try to catch it and pull it down even more. So let's go ahead and give it a shot. A little stringy. All right. that's doing better. I think I'm going to try a little bit of lubrication. We'll use this anchor lube here. Don't want to pack them in too tight now. Okay. Alright. I think that'll work. That looks pretty good. Got a nice smooth looking hole in there from the reamer. Alright. And of course I'm going to take this out and we'll chamfer it just a little bit. So I'm just going to offset it 1.5 inches. That's what my center to center is. And I'm going to repeat it, drill it. It's everything I just showed you. So we'll bring you back whenever I do. We're going to square up this edge and we'll flip the block around and we'll square up the other edge also. Alright, we got the 2 holes drilled and reamed. Now we're going to do some milling just to kind of clean up this side of the block. And I want to point out, I'm using the narrow field of view on the GoPro. It kind of zooms in a little bit tighter, so we're going to see how that looks. I don't know how that's going to look on that one right there, so let's give it a shot. All right, let's put this in high gear. We'll try that speed there. Start with a light cut, make sure it's going to work right here. It's 20 thousandths. Go 30. Yeah, I think they got it. All right, that did pretty good. That was just a 4 flute 3/4 end mill. I'll do some deburring on that. So just flip it around, and that way we can square up the other side. And then after we square it up, we'll go ahead and machine our notch on the one side. We're just going to clean up this side, same like we did on the other. And there's no real specific size. Once I get it squared up, I'm going to measure it with the calipers and see if it's really close to a nominal. And if it is, we might just true it up to that. The bandsaw cut on it's a little crooked, not square. I'll show you what I mean. See that? Tell you what, let's go ahead and get a measurement right there and see where we're at. Okay, I'm thinking 5 3/16. That's 5.199. So let's go ahead and take another 10 11 thousandths and see if that'll clean up. If not, we'll just have to take a little more. I'm gonna go ahead and set my zero. No, it ain't gonna get it all. Not gonna get it there. Just have to take a little more till it cleans up. I don't want to take a whole bunch of unneeded metal off of it. But there's our 5 3/16 right there. Okay. Man, there's a little spot right at the very bottom of that right there. That's gonna bug me if I don't take it off. I'll regret it for the rest of my life. All right. Tell you what. We're gonna make it 5 inches, 5/32. That'd be 5 inch 156. So I'm gonna take another 10 thousandths, and that's gonna be it right there. That way I know it'll, that bottom side right there still has just a tiny bit of saw cut. Okay. All right, that's good, guys. That'll work. Let's see how close I hit it. 156, 157. I think that's close enough. All right. Let's move on. I'm going to change some cutters out. We'll. I'm going to figure out how deep I want the slot to go, and then we'll start milling that out. All right, we're going to test out that narrow field of view again. See if I can get you in a little bit closer. All right, so here's my Sharpie marks, and this is just to outline where that slot's going to be. I'm probably going to try this 1/2 inch high helix end mill and see how it cuts this copper, and maybe we'll come back once we get it milled out and possibly just come right here to the corners with a smaller end mill and just plunge down, have a little radius right there so that we have a true connecting corner. And again, this will all be hidden, so you'll never ever see that. So we're just going to find center. I'm using a 1/2 inch edge finder. Just gently go into it till you just see it kick off. All right, set my zero there. 3 inch block. That's 1.5 inches plus 1/4 inch, so we're going to go 1 3/4 inches. All right, we're going to zero there, and I'm going to use one of my little pancake indicators here on the knee here, and I'm going to preload it about a 1/2 inch. I'm going to set a zero, and that'll easily allow me to just run back and forth and not have to worry about the backlash in the screw around here. I'm going to try this high helix end mill here, and I decided we're probably going to go 3/8 deep. We're going to go 3/8 deep, and then our length there is going to be 2.5, and we're going to be 1 3/4 wide. So the Sharpie lines are just a reference of where the slot's going to be. Okay, I've already got my zero set. I'm already in the center here, and I've got another indicator on the knee, so I can do my offset and not have to worry about backlash. Let's see how 1/4 inch is going to react. Got my zero there. It's actually doing pretty dang good. back. Oh, here it is. That milled pretty good. Didn't know how it was going to do. Okay. I'm going to go ahead and take another 1/8 of an inch. I'm at 250 now, so we're going to go to 375, and then that's going to be our depth. And the reason I'm doing that is because the thickness of the ground clamp is around 225 thick, so I'm just calling it 1/4 inch, and that's going to give me an 1/8 of an inch gap here. Whenever I go to, bend down there and stick that in, it's not such a tight squeeze to get up in there. I've got a little bit of clearance, so that's what my old theory was behind that. Looking pretty good there. All right, let's offset it. We'll go on over to our 5/8. All right, that's looking nice. By the way, I cleaned all this off, so what I'm doing is I'm just trying to leave what chips I can right here on the machine. When I get through this milling, I'm going to sweep them off and put them in a little coffee can or something, and if I ever go to the scrap yard, I'll take them and sell them. Might get a few bucks out of them. All right, we'll try that shot. All right. 1, 2, 3. Getting a little bit warm there. We only got one more cut, and I think we'll be through. I'm gonna go another 325, and that'll make it 5/8 to that side. We'll probably go in there and clean that back side up a little bit more. All right. 1, 2, 3, 25. I think we might go in there and just skin just to clean them sidewalls up. Not that it really matters, but it's mine, so I guess I'd rather see a nice perfect cut before I bolt it on. Well, that actually machined a lot better than I thought it was going to. I know how gummy copper can be, but this is done pretty good. I don't know what alloy that is. It's just sort of a mystery metal. Just skinning it. Five thousandths. All right, 5 thousandths. No, they ain't gonna do it. Okay, there we go. Oh. My hand hit the mic right here. 1 3/4 wide, 2.5 inches deep. Well, maybe 2.5 long, and then it'll be 3/8 deep. All right, I'm gonna go grab the ground cable, and we'll see what it looks like. All right, here's the ground clamp. So this is what it's gonna look like when we clamp it on. Just like that. Okay, the bottom's hitting the vise there, so it's not going all the way to the back. I can unclamp it like that, but it's at an angle. But if I pull it out, right there shows the clearance. I'll push it against the back there. So, you know, I gave myself about 1/8 of an inch clearance so that when I bend down there to install this, it's not so dang tight right here that it tries to hit every time. So I think that'll work right there. And we'll do some deburring and stuff, and I don't know if I need to put any angle on that or not. Might not hurt to put a little bit there, but we'll see. So anyway, there's the general idea right there. So I hope that makes some of you guys happy, and I think it's going to work out good and be just fine like that. So I decided I am going to go ahead and mill a little bit of an angle right here on this edge. Just a little bit of a lead-in angle. And I wanted to kind of point out my buddy Stan over at Bar Z. I'm using his Z squares that he gave me. These are your 3060s, the right and left pair. And I put them in here like that. Use the fence, put them on each side, set the block on it, and tighten the vise up. So Stan, I don't think I've showed you using these for anything yet. I've used them a few times, but I never did show it. So there you go, man. I wanted you to see that. Pretty cool. Okay, that should work pretty good. I'm happy with that. Just another angle of it so you can see. Alright, so I moved on to the next phase of the block, and that is I'm going to equally mill off each side of this. I'm going to take a 1/16. I'm sorry, we're going to take an 1/8 of an inch off each side. That's going to make the block 2 3/4 wide. Right now it's right on 3 inches. I mic'd it and it's like 2/1000 over 3 inches. So we're just going to mill it down. I'm using an 1 1/8 2-flute end mill. I'm trying to get it all in like one pass across there. So let's see how she reacts, okay? By the way, I am using the zoom mode on it, or narrow field of view. And we're trying 48 frames per second here to see how it's going to come out. So I don't want to take it all at once. I'm going to try a 1/16 first and see how it looks. Alright, it's a little gummy. It's trying to stick in some spots right there. I don't know. This is a used cutter, but it looked good. I think it's just a little dull. Alright, so I wasn't having any luck with finding another good cutter. I've tried a couple different ways to mill it, and it always wants to come back and rub, and it just leaves these little fuzzy marks on here, these little high spots, and it's because of the gummy material. I even tried a little bit of that anchor lube, just a little swat across there, and it didn't really make any difference. I tried this carbide insert mill right here, no dice. So I'm going to go back to my 1/2 inch high helix end mill that I was using because it worked fine, and I'll make three cuts across it, and it'll have those little milling marks in it, kind of like you see on the CNC machines whenever they're doing their cutting. See if a little bit of lube will help it. Okay, I think we're all the way down in there actually. I'm going to go ahead and move on and try to get these 2 bushings machined. I'm going to use the 1 1/4 phenolic, and we may just make a nice little skim cut across the outside just to clean it up. So basically I'm going to face it off, and we'll turn it back. You'll have a shoulder, it'll be drilled, and then we'll part it off. I'm going to make 2 of them. Okay, I just got my zero set, and we're gonna go ahead and start turning it down. I'm gonna make me a little mark here. Well, there's that smell. No denying it's phenolic. There you go. Now you can see the grain structure a little better in it with the fibers. Okay. I was just taking 100 thousandths there. Yep. So we're going to be bringing this down to 3/4. And I went ahead and mic'd the holes with my telescope gauge and my mic, and it's measuring 751. So I'm going to try to make this 752. Give it a light little press fit in there. All right. Let's see if I killed it. Just about right there where I want to be. 2 over. All right, I'm going to go ahead and just take a little skin cut all the way down here, just to make the OD look consistent with the rest of it. Okay. I just went in there with the little tri-blade Noga just to break that edge right there. All right, we'll go ahead and get this first one parted off. I've got my link set there. I'm going to run this little rod up in there, and I decided to make the flange thickness right here. We got it at 3/16. I had it at 1/8 of an inch, but I think 3/16 looks better to me. So we're going to run with that. All right, just going to go in there a little bit. Let me grab my file. Okay, there we go. There's our first bushing. We'll do a little deburr on the back of there. Let's make one more and we'll get it pressed in. Alright fellas, we're almost done. Okay, so here's your close-up of the phenolic bushings that we're going to install right there. They're going to get pressed in. Okay, but before we do that, I want to do one other thing. I wanted to see how this would polish up, and I'm not talking spending a bunch of time polishing it. I've got something here that I've used for a while. It's this Miracle all-purpose polishing cloth with coconut oil, and this one's about dried up, but that's what the bag looks like right there. And I've actually ordered me another one because I forgot that this one still works, but it's just about dried up. Whenever you get them new, they feel a little bit moist, but that's what it does when you start polishing. It turns like a black color. But they have a very pleasant smell. It smells like coconut, but it does a really good job on copper. I'll tell you that. You can take a penny in this, you know, and polish it, and it shines better than new. So I actually hit it right here in the middle a little bit just a little while ago, just to see what kind of reaction it would do. And my hands are dirty, so I'm going to get fingerprints on it. I'm just trying to give you a shot of everything so you can see the sides. The sides are lightly sanded on with 220 like that. So let's see what this does. By the way, I got you in zoom mode, or narrow field of view. So give it a little rub. And I've got my new one ordered. It should be here in a few days or so. So my plan is, by the time this is ready to go on to the welding table permanently, I'm going to do another buff with this polishing cloth. But because what it does, it almost like it puts a light wax on there. It'll help protect it. So I don't know if you can tell. I can't tell where the reflection is, but it does a good job of just making it look really nice and shiny. But all right, so that's kind of just a little demo of how this polishing cloth works. So again, if you're interested, look that up, Miracle polishing cloth. I just bought mine off Amazon. They're only like $6 or $7, and it's great for any metal, especially copper, brass, aluminum. It does excellent on also, and I think any metal. So all right, let's go ahead and go get our bushings pressed in. Okay, all right, I got the first one. I just kind of started it in there by hand, and I put this clean rag down there just so if there was any grit or something stuck to the metal, that it wouldn't transfer into the copper block. Just a light press fit, just enough to keep it in there. There we go. Oh, dang it, wrong side. No, I'm just kidding. There we go. All right, let's mount her up, test fit it. All right, there she is. Now, don't forget that we're gonna have a 3/16 phenolic plate here, which actually is this plate. So it'll be sitting like that, and this is going to be sitting on top of that. Okay, so I think whenever I use my phenolic plate underneath it, I'll be able to use these bolts here. Okay, but they're a little too long right now, so we can just use the ones that I showed before. It's just enough to hold it there. Okay. All right. So you probably want to see what the ground strap's going to look like. All right, be like that right there. Except it'd be the other way around. I think that's going to work great, man. Just for a ground in general, should work pretty good. So, All right, our next phase is going to be forming up these and getting them machined so that they bolt on here. So I've got the plate milled, and I can see that they're sprung out a little bit. So we're going to get to this next. I'll see about forming some radiuses where they'll come around the shaft on each side and come across, and we'll see about attaching the spring back there. Okay, and then I'm probably going to slot for the bolts here. That way I can adjust these a little bit according to the radius down here on the end. All right, so that's where we're at, guys, and personally I'm pretty happy with it. I think everything's coming out pretty good, and I think it's going to work great too. So hope you enjoyed watching this build, and we'll be back for some more. Okay.